Hello, this is Chuck Ridgway, Automation Technology Manager here at Horner. And this week we're starting a new series, a new how-to series. And today's show is all about Modbus RTU Slave and Modbus TCP Server. So joining me today is my colleague, Mr. Casey Gardner. How you doing, Casey?
Hey, not too bad. How's it going, Joe?
It's going well. And we were talking before the show, and you mentioned that you were just helping a customer today with this very feature.
Yeah, absolutely. It's a common application for sure. We had a customer looking to integrate us with a SCADA package, so Modbus TCP Slave, very easy configuration and just a little bit of info on the Modbus table, and they're good to go.
Right, that's correct. And it's really all about, there's a little bit of setup required, but a lot of it is really all about how the mapping works between, Modbus and the Horner variable table or register table. And we'll cover all that today, of course. And while Modbus TCP is the most common connection for SCADA packages with the OCS, there are some scenarios where a serial port connection might be made, like, for instance, maybe with a radio modem, for instance.
Absolutely.
Yeah, that's really common for water treatment applications, maybe wastewater applications where you've got remote lift stations and those sorts of things. Okay, we're going to go ahead and get started. This week, Casey is manning the chat, so if you have any questions and you're watching this live, chat them in, we'll get them answered. If you happen to be watching on replay, we still want your questions. Just type those into the comment section and we'll get those answered in a timely fashion. Okay, let's go ahead and get started. Okay, how-to, Modbus Slave and Modbus TCP Server. Here's our program for today. We're going to talk about applications for this feature, go through the basics of Modbus protocol. We had a pretty extensive Modbus webinar back in 2020. For those of you who are looking for an in-depth look at Modbus in terms of the message structure even, feel free to go to our website and check out that webinar from last year. I'm sure at some point we'll also include it in the comment section as well. We'll also be covering today, of course, setting up Modbus over a serial port, as well as setting up Modbus over Ethernet. And again, in both cases, the OCS is acting either as a slave serially or as a server over Ethernet. And of course, we'll spend some time on some demonstrations. Okay, so from an application standpoint, what is Modbus useful for? And specifically using the OCS as a Modbus server or a Modbus slave in the case of serial. Well, really, Modbus is the most common way the computer software packages can retrieve data from an OCS, whether you're talking about a SCADA package like Casey was earlier, whether you're talking about data historian type software, whatever the case may be. And in this scenario, the OCS again is acting as a Modbus slave or a Modbus TCP server. Now, the OCS also has the capability to act as a master in a serial network or as a client on an Ethernet network, but we're not focusing on that today. We've also got some advanced serial capabilities in terms of report by exception and those sorts of things. We're not going to be covering those either. Today is really all about the basics of Modbus slave functionality or Modbus server functionality. Okay, let's start with the basics for Modbus. Just as I mentioned, the most common industrial protocol to allow multiple manufacturers' equipment to talk to each other. It can be used over a variety of different types of media or connections, serial ports, radio modems, Ethernet, to name a few. Modbus is a master-slave protocol when you're using it serially or over a radio. It's a client-server protocol when you're using it over Ethernet. Now, Modbus data is modeled around a traditional PLC. And back in the late 70s, believe it or not, that's when Modbus was invented, a PLC effectively looked like this. You had a device with digital inputs, digital outputs, analog inputs, analog outputs. All data was either Boolean or integer based. So that's the data model that Modbus was established under. Now, from an address numbering standpoint, Modbus is a 1-based addressing scheme. So the addresses you can see start with 1, they don't start with 0. Now, the original address scheme for Modbus is 5 digits. So that means it can support up to 10,000 each of the 4 different data types. However, a newer addressing scheme, which has been added, which is a 6-digit scheme, now supports up to 65,000 types, or 65,000 of each of the 4 data types. Now, from a Horner OCS standpoint, we support both addressing schemes. So if your software, whether it's SCADA software, Historian software, whatever the case may be, if your host software only supports a 5-digit scheme or only supports a 6-digit scheme, not a problem. The OCS can support both. Okay? In terms of what is the mapping, or how does a Modbus address correlate to a OCS register location? Well, there's a fixed memory map when you're talking about using Horner Advanced Ladder or our traditional Horner IEC languages. So that fixed memory map establishes the relationship between the Modbus address and the OCS register. And we've got that table up there on the screen, as you can see. So, for instance, Modbus outputs are mapped to OCS Q, M, and T bits. Modbus inputs are mapped to I bits on the OCS side. Modbus analog inputs are mapped to AIs on the Horner side. And then Modbus holding registers are mapped to AQs and Rs. And there's a couple of different ways that you can access the R registers, depending on whether you're talking about a 5-digit addressing scheme or a 6-digit addressing scheme. Now, I will mention that you can also access system registers, system bits, keypad bits, display bits. Those are also accessible. I just don't have them shown here on this particular chart. But in the Horner Ethernet supplement, a complete map that's comprehensive with all data types is shown. Now, in addition to, of course, the 4 different data types we've talked about with Modbus, Modbus uses something called function codes in the process of reading or writing data. Okay, the most common function codes are shown in the chart to the right. Now, the function codes define the memory type to be addressed, digital inputs, coils, holding registers, etc. Also defines whether it's a read function or a write function. Now, you'll notice that on the chart there, you'll see terms such as force and preset. Those basically just mean write. And again, the common function codes are shown on the right, and those are all supported by the Horner OCS. Now, there are additional function codes that have been created over the years, but it's less universal in terms of which devices support those. So the OCS has been pretty consistent in mainly supporting the most common function codes. Okay, as you see from this updated chart, if you kind of combine the Modbus function codes in a new column, you can see which Modbus data types, and therefore which OCS data types, are acted upon by the different Modbus function codes. Now let's get into the setup procedure for using Modbus over a serial port with a Horner OCS, again, where the Horner OCS is acting as a slave. Again, we have the capability of being a master, but we're not going to cover that in today's program. Okay, so the first step really is you need to get your cable pinout correct. There are a variety of ways to connect an OCS serially to a computer or to other industrial devices that have serial ports, but the 2 most common are shown here. The most common by far is RS-485 half duplex. Now, with RS-485 half duplex, you literally only have 3 conductors typically. You have a plus conductor and a minus conductor, and over those 2 signals, transmit and receive is a shared function. In other words, you don't have a dedicated transmit signal and a dedicated receive signal. The transmit and receive functions share those 2 conductors. So that's why it's called half duplex, because you can only transmit or receive at one time. Now, another common interface is RS-232 Now, of course, RS-232 is limited to point-to-point communications only. With RS-485, you have the ability to have one master connected to multiple slaves through a multi-drop type scenario. With RS-232, it's strictly point-to-point. Now, there's still most commonly 3 conductors used, but this time, instead of a differential signal, it's a single-ended signal, so therefore you do have a dedicated transmit line and a dedicated receive line. So again, the first step is to get your wiring diagram right. You'll find all the wiring information with the cut sheets for the Horner OCS, and here are the 2 most common wiring diagrams. All right, so once you've got your cabling or your wiring correct to connect the OCS to the other device, which is typically going to be a computer, now you're looking at the important setup parameters to get Modbus slave working over the serial port. Okay, let's start with a Modbus ID. When you're talking about Modbus serial, every Modbus slave must have a unique ID numbered between 1 and 247. If you're talking about a point-to-point connection between a master and a single slave, certainly slave ID of 1 is going to be the most common, but it doesn't have to be the only one that's used. Another thing that needs to be configured is a Modbus timeout. So let's say that you're a slave and you are fairly dependent on your data communications with the master. By programming a Modbus timeout into the slave effectively can detect that the master hasn't talked to it for quite a while, and based on that timeout, it could decide to start going to a safe condition, maybe turning its outputs off, whatever the case may be. So a Modbus timeout is an important setting in a Modbus serial slave that allows the serial slave to effectively take an action if the Modbus master goes away. You need to configure serial mode, of course. Are you talking RS-232? Are you talking RS-485? You need to talk about handshaking. You know, what is the handshaking between the 2 devices? Now with RS-232, no handshaking is nowadays the most common because of the fact that most modern electronic devices typically have big enough buffers where the hardware handshaking, or even the software handshaking for that matter, is less of an issue. So none is the most common for RS-232, for instance. Now when you're talking about multi-drop RS-485, then a half duplex type handshaking is specified, because with half duplex RS-485, not only can only one device talk at a time, but also they're sharing the same lines between transmit and receive. So special half duplex handshaking is required in that case. Now from a protocol standpoint, there's actually a couple of different variations of Modbus serial. There's something called Modbus RTU, which uses binary coding and is more efficient. And then something called Modbus ASCII, which uses English readable ASCII characters as part of the communications. Again, ASCII was much more common years ago, and it's still around today, but Modbus RTU with binary coding is by far the most common. And then you've got baud, parity, data bits, stop bits. Effectively, even if you don't fully understand what all these different settings do, the bottom line is those settings effectively set the bit rate, or the speed, as well as the construction of the messages that are sent out over the wire, okay? And the big thing is, as long as those settings match on both the master side and the slave side, then generally you'll be good to go. All right, so we've talked about the parameters that are important for Modbus over serial in general. Now let's talk specifically about the OCS. How do we actually set up Modbus serial protocol as a slave on the OCS side? Now, actually, I think a lot of you might expect that we would go into the hardware configuration and we'd go into the serial port section of the hardware configuration to actually configure an OCS to be a Modbus serial slave, but that's actually not the case. We actually have a couple of function blocks that we need to program in ladder or in whatever language we happen to be using with Cscape from a control standpoint. So if you're talking about advanced ladder, whether that's variable-based or register-based, the first thing you need to do is you need to perform a open COM port function block. So you need to program one of those into your logic. Almost always, you're going to be just using an always-on function block before that open block. Now, back in the day when most OCS products only had one serial port, and we're talking a long time ago, you may want to share that port, so therefore you wouldn't use an always-on block, or contact I should say, in front of that open block. But these days, you're going to have dedicated functionality in each port, so the always-on contact makes sense. And then in that open function block, you're effectively configuring which port you're going to use, and most OCSs have at least two. You're going to select the baud rate, parity, data bits, stop bits, again, to make sure that the speed as well as all the parameters are matching on both sides. You're going to select your handshaking, again, most typically none for RS-232, or multi-drop for half duplex for RS-45. You're going to select whether you're talking ASCII or RTU, and you're going to decide whether that port that you selected, are you going to be using it in RS-232 mode or in RS-45 mode? The reason that's important is because even though the MJ1 and MJ2 ports are fixed at either 232 or 485 respectively, for products like the XL7 and the EXL10 that have an MJ3 port, it can be configured between, the same port can be configured between 232 and 485. So that setting needs to be made. So that's an open port function block that is required if you're using Modbus over a serial port as a slave. Now, after you've configured your open function block, there's still one more function block to go, and that is a Modbus slave function block. And this covers all the Modbus specific parameters that are required, such as, again, the port number to match up that port open function block you just performed with this particular function block. You need to configure the Modbus ID, and remember, for Modbus serial, you're talking somewhere between 1 and 247 for legal IDs. You're going to want to configure that Modbus timeout so that the OCS can effectively keep track of how long it's been that the master has talked to it. And if it's been beyond that timeout, the OCS can take corrective action. And then you can also configure a status register so you can detect inactivity, those timeout errors we talked about, or timeouts we just talked about, as well as any kind of framing errors or CRC errors or any other kind of communication errors. I notice way too many customers not taking advantage of status registers when they're doing communications because we do make them optional, but you should always take advantage of status registers because they can really lead you down the proper path in your troubleshooting. Okay, so once you've effectively opened the port with the open block, and then you've executed your Modbus slave function block, at that point, the OCS is fully ready for Modbus slave communications. No additional programming or configuration is required. As Modbus requests come in over the serial port, the OCS will just respond to those automatically. Okay. So the next thing I'm going to do is I'm going to go ahead and we're going to show you how to perform this setup on the OCS side. And what we're doing is we've got an example application here where an OCS is controlling temperature on a machine. So it's a temperature control type application. We're going to go ahead and show you how to set up Modbus RTU serial in Cscape. We're going to make process data available over Modbus by assigning registers to variables. So we're going to actually map Horner registers directly to our variables so that that data is now available over Modbus. Now, I'm going to be showing you variable-based advanced ladder. And with variable-based advanced ladder, one thing you'll remember is we don't typically map traditional registers to variables unless we have to. When do we have to? Well, we have to do mapping to traditional registers for real-world I/O, I's, Q's, AI's, AQ's. And then in the case of Modbus, when we want variables to be accessible over Modbus, that's another scenario where we actually have to map our variables, at least the ones that are going to be mapped to Modbus. Those particular variables have to be mapped over to traditional registers as well. Okay? And then once we've done that, we're going to go ahead and fire up a Modbus utility on a PC and make sure that we can successfully read and write Modbus data to and from the OCS. And then once we're done with that, we're going to show you the same setup exactly for Modbus TCP. And I don't even have any slides on Modbus TCP in terms of the setup because it's so straightforward. So we're going to go through that just with a demonstration. Okay, so let's go ahead and get started. Let me go ahead and fire up Seascape here. All right. Now let me go ahead and bring in my OCS. All right, so I've got an XL7 here, as you can see, and you can probably tell from looking at the screen, it's a temperature control application that we're simulating here. So we've got a set point for the application. We have a current temperature for the application. That current temperature is shown in both a data field as well as a bar graph. And then we've also got a manual control for the heater output and a pilot light that's kind of indicating the current status of the heater output. Okay, so this is the machine that we're going to be connecting to a computer, and we want the computer, whether it's for SCADA purposes or historian purposes or whatever the case may be, we want the computer to communicate with the OCS over Modbus. We're going to show first doing it Modbus serial. Next, we're going to show over Modbus TCP. Okay, so let's go take a look first of all at our Modbus serial configuration. And this is exactly what I just showed you on an earlier slide. And that is, we have an always-on contact. We've got a open COM port function block here, and we've selected our port. We've selected our connection parameters. We've decided that we're going to be using Modbus RTU protocol, which again is the more common between Modbus RTU and Modbus ASCII, especially these days. As you can see, there are other options for the COM open block, including CSCAN serial protocol, as well as just generic protocol like you might use with a barcode reader or something. But again, when we're talking about a Modbus application, we need to really select between Modbus RTU and Modbus ASCII. In my case, we're going to be looking at Modbus ASCII. Now you'll notice down here the mode is really grayed out, and that's set at RS-232. That's because I've selected MJ1, which on almost all OCSs, MJ1 is fixed at RS-232. So if I want to select something other than RS-232, I'm going to have to pick a different port. Okay, so that's my open function block. Now, as soon as my OCS starts scanning the ladder logic, really as soon as it powers up, it obviously is going to execute this open function block. As soon as the port is successfully open, this internal contact here or coil is going to be turned on, and that in turn will enable this Modbus slave function block. So let's take a look at the configuration here. Now, you'll notice that there are quite a bit of configuration options with this function block. At the top, we have the basics. What is the slave ID? Remember, the slave ID needs to be between 1 and 247. What is the timeout? And that's in milliseconds. How long is too long for the OCS to be communicated with by the master? And then here's our status variable that we've assigned. I've named it Modbus status. And again, it's important when you're doing communications to take advantage of status. Now down here, next, you'll see we do also have an additional variable that's optional. So if we want to be able to use a bit type variable to on the fly or even permanently prevent the OCS from being written to. So in other words, you want to be able to provide access for Modbus for reading, but not for writing. If that was the case, you would enable this variable here and you'd create or assign a variable to prevent the OCS from being written to. Now, if it's a variable that you could turn on and off, you could make this change on the fly. If it's something you just wanted to completely disable writing to the OCS over Modbus at any time, you could assign the always on bit here, and it would permanently inhibit Modbus writes. But in my case, I don't want to do that, so I'm going to not select that option. Now down here, we have some really pretty powerful advanced features, including exception messages. So that's something called report by exception, as well as store and forward. So those are a couple advanced features that we're not going to cover today. Exception messages are the ability for the OCS, even when it's programmed as a slave, to send out a message, to initiate a message whenever a particular exception occurs in its program. And I'm not talking about an exception like a memory leak or a memory error. I'm talking about an exception where I've programmed something into the logic and oops, I've got an alarm condition locally here. I don't want to wait to be polled by a master before that alarm condition gets reported. I want to report that condition myself and initiate the communications myself. So that's called report by exception. Now, it's not an official part of the Modbus spec. So every manufacturer kind of adopts their own scheme, and that's no different with us here at Horner. So we're not going to cover that today, but just be aware that's what that functionality is for. And then store and forward is an advanced function that allows a slave to effectively pass a message along to another slave. And that's typically used in a radio or wireless type application. So if the master is able to communicate wirelessly over a radio, for instance, with one slave, but the only way he can reach another slave is for that message to be passed on from the first slave to the next and on down the line, then you could implement a store and forward scheme. So that's what that feature is all about as well. But again, that's beyond the scope of this particular program today. So again, just a couple parameters. What port am I using? You need to match up the port that you've opened. What's my slave ID? What's my timeout? What's my status variable? And do I want to either on the fly or permanently disable writing to the OCS over Modbus? Okay, so that's really all that's involved programming-wise. So once I've downloaded that program into the OCS, it effectively powers up, and it's immediately, as soon as those function blocks are executed within a couple scans, it's immediately ready to start receiving Modbus messages. Okay, so let's go ahead and fire up a utility now on a computer. We have a utility called Modbus Poll, and that's a pretty popular utility that is available commercially to, let me go ahead and close it and reopen it again. I've just got the demonstration or the evaluation version here. Okay. So let's go ahead and first we need to establish a connection. And the first thing I want to do is establish a serial connection. Now it turns out the connection between my computer and this XL7 is just through MJ1. That's what I just programmed. That's RS-232. And I've got a USB to 232 adapter plugged into my PC. So let's go ahead and make that connection here. So I'll go under connection here and I'll select connect. Okay, I'm, again, an unregistered user here. I do definitely recommend this software for those of you who are doing a lot of Modbus work. It's good software. It allows you to do a lot of testing to validate communications with slaves independently of having both devices that ultimately will be connected to each other connected to kind of verify the communications. Okay, so my connection is going to be over serial port. This is the port I want, okay? That's the USB serial port. That's COM9 that's connected to my computer. I have to make sure these parameters match up with what I have configured in the OCS, and they do. I have selected RTU mode, not ASCII mode. My timeout is set for 1,000 milliseconds. Now, that's not the same timeout that is programmed in a slave. This is how long this computer, using this program, is going to wait for the slave to respond, and it's going to wait up to a second. And then this is the delay between polls of data that the software is going to wait before it pulls additional data. So that's the parameters I have set here. Okay, so you can see we've got some good communications going here, but we don't really have any data transfer happening. So the first thing is, well, what Modbus register am I actually going to be reading if I want to get data out of this OCS? So if the data that we want to get from the OCS, you can see there on the screen, you're talking about the set point. All right, when I say the screen, I mean the OCS screen. You want to probably be able to monitor and even change the temperature set point. You want to be able to monitor the current process temperature. You probably want to have the ability to actually remotely, manually activate the heater if that's a function that you want to perform over Modbus. So that's the data we're after, but that data has to be mapped into Modbus register space before that can actually work. And I'm using variable-based programming. So with variable-based programming, there is no automatic mapping to OCS register space, which means there's no automatic mapping to Modbus register space either. So that means we need to do that manually. So I'm going to go ahead and go back into Cscape. And I'm going to take a look at my variable table here. And I'm going to show you the fact that, yes, I better scoot it over so everybody can see it. I'm going to show you the fact that I have indeed, for the variables in my application, I have gone ahead and mapped them to Horner register space so that if they're available in Horner register space, they're available in Modbus register space. Because remember, there's an automatic mapping that goes on between Horner registers and Modbus registers. Okay, so for my process set point, I've mapped that to R1. For my current process temperature as an integer, I've mapped that to R2. And just to make things interesting, my process temperature as a real, I've mapped it to R3. Now, Modbus is completely an integer-based protocol, but double integer data and IEEE floating point data is really just multiple words concatenated together where both sides of the communication, the OCS side and the master side, both need to understand what the formatting of the data is so that it can be interpreted properly on both sides. So again, on the OCS side, when I map the real version of my process temperature to R3, what I'm doing is I'm actually mapping it to R3 and R4, and those 32 bits are being handled as an IEEE floating point value. Okay? Now, as long as the software on the computer side can interpret those two consecutive words as a 32-bit real value, then the two devices are communicating successfully. So that's something to keep aware of. Modbus is completely integer-based, but you can have integers that are concatenated together in consecutive addresses, and as long as they're interpreted properly on both sides, that's going to work just fine. Now, in addition to these integer-type data and real-type data, I've also mapped my heater output to Q1 for two reasons. Mainly because it does need to be mapped to Q1 if it's a real-world output, and I've got it physically connected to Q1. And then because of the fact it's mapped to Q1, that also makes it available over a Modbus address. Okay? And then for my remote ability to turn the heater on manually, I've mapped that to T1, which again also has a Modbus address that's assigned to it. Okay, so let's go back to Modbus poll, and let's see if we can get some of this real-world data. All right, so I'm going to go, and I've already done my connection. I'm successfully communicating. Let's go ahead and set up some data. So I'm going to go ahead and configure read-write definition here. All right. Now, my slave ID, what is that? It is 1, so I want to leave that as 1. The next thing I need to configure for this particular software package is the Modbus function that I want to use. With some software packages, you'll just type in a Modbus address directly and you'll be good to go. With others, you need to specify the function and then specify the address. So with Modbus poll, we start with what function in Modbus we want to use. Now, we want to read holding registers. That's ultimately where my process set point and my process temperature value are mapped in Modbus space. They're mapped to holding registers. Now, which holding registers do I want to read here? If I were to pull up the Horner holding register map as it relates to Modbus, you would see that R1 is mapped at Modbus register 43,001. So what I need over here is for this address to end up at 43,001. So with Modbus poll, I have to type in an offset here to get me to that particular address. So if I type in 3,000 for my offset with this software, I'm going to end up reading register 43,001. That's what we want. Now, I don't want to read 10 consecutive integers. I want to read 4 consecutive integers. Okay, and I'll pull them every second or so. That's fine. I'll hit apply, and I've got real data. Okay, now what do I have here? Well, 495 is my set point. So if I go ahead and adjust my set point, let's say to 497 remotely, you can see that's changed here. I can even double click there and make that change from here as well. Okay, so I'm successfully There we go. I'm successfully reading and writing that particular piece of data. My process temperature, okay, I'm reading that successfully. That's a read-only bit. I can't really change that. I could try and change it on the Modbus side, but it's not really going to change on the OCS side because that's actually my temperature. But what's going on here with these two words? Well, they're not being interpreted properly. They're just being interpreted as integers. So if I want these to be interpreted properly, I need to set up my software on the host side to tell the host software what kind of data we're looking at here. So with this software, I can pull up format, and it just happens to be 32-bit float. And because there are different ways in which different Modbus devices can put the order of the bytes and the order of the words, there's 4 different options here in terms of how the data is formatted. In our case with the OCS, it's a little endian byte swap. And when I do that, you can see, all right, there we go, 495. All right, so we were successfully able to read and write, in some cases, Modbus data from this computer to the OCS over Modbus serial protocol. All right, now let's go ahead and take a look at the coil or the contacts and how we can potentially read and write those. So we'll just do that real quick here. So let me go ahead and go back into the connection. This time, back into the read-write definition. And this time, instead of selecting holding registers, I'm going to select coils, okay, because that's where my T and Q bits are mapped in the OCS register space. All right, and the one I'm interested in, let's start with the one that will effectively allow me to remotely turn on my heater. So that one is, in the OCS, is mapped as T1. And if you look at the OCS to Modbus map, you'll see that T1 maps over to 6001. So if I type my offset of 6000 here, I get 6001, which is what I want. I hit apply, I say okay, and there we go. I've got my register here, okay, which I can read. All right, and let's go ahead and switch that. All right, and you can see what's happening. All right, so it's actually the first one I'm interested in, not the second one. And then if I want to go ahead and change that, I should be able to do that. And we should be able to see the result. And we do. Okay, so that's really what we're talking about in terms of Modbus serial communications, setting it up on the OCS side, and then using some sort of Modbus utility for testing purposes to validate our communications and everything. Okay, so I'm going to go ahead and close this program, and I'm going to go back into Cscape, and you're going to be very impressed at the amount of configuration that's required, or the lack thereof, to be able to do exactly what we've done here, but now do it with Modbus TCP instead of just Modbus serial. So let me go ahead and show you that now. Okay, so we're in Cscape. I think we're pretty much done with our XL7 at this time. So if we're going to set up this OCS as a Modbus TCP server, all right, which is effectively acting like a slave on Ethernet, the first thing we need to do is make sure our Ethernet is configured properly. Now, this is an XL7. The XL7 has 2 Ethernet ports, LAN 1 and LAN 2, and both Ethernet ports can be used for Modbus slave operation, which from an Ethernet standpoint is Modbus server. Okay, so the first thing I do is decide which LAN port I'm going to configure. I'll go ahead and configure LAN 1. I need to make sure that my IP address and my net mask at the very least are configured. With those configured, I can at least talk over my own subnet. And then if I'm going outside of my own subnet, then I'm going to need to configure the gateway as well. But in this case, I'm not going outside the subnet. Both my computer and the OCS are on the same subnet. Okay, so IP address and net mask in this example is all that needs to be configured. And then lastly, I just need to check under resident protocols, I just need to check Modbus slave. Now, we really probably should change this to say Modbus server, because that's more correct when you're talking Modbus TCP over Ethernet. But that's really all you have to do is check this checkbox. Now, there are some other options available. So while this is highlighted, I can hit Configure Selected Protocol. I can select, instead of Modbus TCP, I could select Modbus UDP. Why would I ever want to use UDP? Well, remember, TCP is an Ethernet protocol that comes with guaranteed delivery built into the messaging. So when I send a message using TCP, I'm pretty much guaranteed it's going to be delivered. And if it's not delivered, the system is going to retry multiple times to try and get the message through. And most of the time that's fine. But if I'm doing communications over a cellular modem or a satellite modem where I'm paying for every byte, that may not be what I want. So in that scenario, instead, I actually might want to use Modbus UDP instead, which does not have guaranteed delivery. But if my message fails, I know it, and I can then just retry again or not retry if that's what I want to do. So with Modbus UDP, you have more control over how much data actually goes out over the wire because there's no retry mechanism built into Modbus UDP. So we've got some customers that prefer to use that, especially with cellular modems or satellite modems. Okay, so in addition to that option, you've also got a port selection. Now the default port for Modbus is 502. 99.9% of the time, there's no reason to change that port number, but if you needed to do so, you would have the ability to do it. And then lastly, that same write inhibit we talked about that was available in the Modbus slave function block for Modbus serial slave is also available for Modbus as a Modbus TCP server. So again, if you want to keep the OCS from being written to either ever over Modbus or just during certain circumstances, then you could assign a variable to that function. Okay, so that's pretty much what I wanted to show you today. The key piece of information you're going to need, really, from a reference standpoint, if you need to do this application in your case, is you're going to want to get our Horner Ethernet supplement. In the Horner Ethernet supplement, that's the documents available from our website. So let's say that you've got an XL4 in your application. Navigate to the Horner website, navigate to the Horner XL4 product page, and then listed under documentation, under the XL4 product page, you'll find a variety of supplements, including the Ethernet supplement. And in the Ethernet supplement is a chapter on Modbus TCP server and Modbus serial slave. And you'll see, it's mainly going to cover Modbus TCP server because it's an Ethernet supplement. But in there is going to be the Modbus map, complete Modbus map between Modbus registers and Horner registers. If you've got that in front of you, that's really the key reference information you need. Okay, I'm going to go ahead and bring in Casey. So how are we doing today, Casey?
Not bad.
Good. Any questions?
Looks like we did not have any questions. We had one comment. Basically, Waldemar was saying it was really nice to have the option to call the open port and Modbus functions through registers rather than specific instructions. So that was kind of a nice feature we've got for sure. Absolutely,
and I didn't specifically mention that, so that's even a better comment. So if you have an application where your communication parameters could change from time to time with different locations of your machine, for instance, and you want to make that configurable from the screen instead of having to get Cscape out and hard code everything again, you can assign variables or registers to all those Modbus setup parameters and change them on the screen instead of from Cscape. So great comment. Thanks for that. Okay. So I want to remind you that every Tuesday we're here at 2 o'clock p.m. Now for the next 4 weekends, we're continuing our how-to series, and because of our crazy schedule this month, we won't be able to be live probably for any of the rest of these sessions. But that doesn't really matter. You're still getting the same good content. Most of you, frankly, watch these on replay anyway when you are needing to work on a particular function that I've described in these videos, along with my friend Casey Gardner. So it's really not that big a change. The main difference is if you're not watching live, whether it's on any of our videos, type questions in the comment section and we'll get those answered. So next week, it's going to be about high-speed outputs on the Horner OCS. Another topic which can be pretty useful for certain applications, whether you're talking PWM, frequency outputs, or whether you're talking about an output that turns on or off based on a particular position. Don't forget to subscribe to our channel and keep your eye out for our next video, which more than likely will be this video upcoming next Tuesday, our next how-to video. But you never know, one of our tech support team might post another video on our website as well. So if you subscribe as well as check the bell, then you can get notification every time we get a new video released on our YouTube channel. And don't forget to check our website as well. Thanks for joining us, and we look forward to presenting a new video to you next Tuesday.